Hey guys, new video for you today. This one's focusing on something called modeling equations. It fits in with PA 6-10 in your workbooks. And so hopefully by the end of this lesson and the end of the practice in the workbook, you can confidently say that I can use pictures and balances to model and solve equations. And so here is where we will start. Just get my pages together. All right, so the first thing that we would like to know is what expression corresponds to this model. And so if we look here, we see that we have 4 boxes and then some circles. We've kind of been working with boxes a little bit. And so if there are 4 of these boxes, what I'm going to say is that there are, you can say there's 4. Oh, I should probably set up a pen. Nice thin line. So I'm going to say that there's 4x. Now, I also hopefully remember that that means x times 4 or 4 times x. But normally when we have an unknown and then a certain group of them, we just write it like this. They have the number or the variable and then what's called the coefficient. And then there's 3 circles here, so I would say that that's 4x plus 3. And so that's called an expression because there's not an equal sign. Now the question to consider here is if there are 35 counters altogether, what equation could we write? So what we would do is we would take that 4x plus 3, and then we'd say that that equals 35. And so it becomes an equation because there's an equal sign here, right? So it changes from an expression to an equation when there's an equal sign. Just challenge you real quick. See if anyone can figure it out. I'm sure a lot of you can figure it out, how many counters there would be in each box. But we can actually try a different strategy to solve this called the organized approach. And so in the organized approach, if we have an equation like 2x plus 5 equals 11, we could say something like this, right? So we have our 2 unknowns, and then our 5, that plus 5, and that's going to equal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that stuff's got to equal. And what we could do is we say, well, we start with 5 over here. And now let's just start adding in an organized way. So that's 5, there's 6, 7, 8, 9, 10, and 11, right? And so you could do it that way in an organized way. Start out and just add counters in each until you get to the total that you're looking for. So here I have 11, and then over here I also have 11. But what we're generally working with is we've been looking at equations like this. Now it talks about pans. So maybe before we do that, if you want to just pause the video for a quick sec and work on the questions on page 73, they generally ask you to identify an expression, identify an equation, and they've got it set up into like bags, and they've got it set up into apples. And so then once you've kind of figured out the equation, they're sort of asking how many apples would be in each bag. And then once you've done that stuff, you can unpause the video and pick it up again. But what it moves on to is something called the pan model. Okay, and in the pan model, and I'm going to make my line a bit smaller again. In the pan model, we're assuming that these things are on like a balanced pan, right? I don't know if you've seen this before, but basically you want to make sure that these two sides, that they stay balanced. And so that means that if you take some stuff away from the one side, that you're going to have to take it away from this side. Now, the equation that we're modeling here is we have one box that's unknown, so we're just going to call that x. We have 2 apples, so we would say that that's x plus 2, and you guys have practiced this already. And then over on this side, there are 7 apples. And so, again, the left side equals the right side. And so whatever number this is, now, guys, we know it's 5. We want to try to show on the balance, on the pan, that it's equal. Okay, and so we have a question here. Each pan becomes a side of the equation, right? So we have, this is the left side of the equation and the right side. That's what's represented over here. We've got to make sure that the number of apples are the same. So the first thing that we do to find the number of apples, we remember that we're working with x plus 2 equals 7. The first thing I want to do is actually just get rid of these 2 apples. And so the way I do that is I'm going to cross them out, but that's going to make our pan unbalanced, right? So if I have this pan over here, and again, this is the equation I'm working with, right? So my pan is, at the start, it's balanced. Now, if I take away 2 apples over here, I have to take away 2 apples over here. Otherwise, my pan will become unbalanced, okay? And so what I've done here is I've taken my x plus 2, but I've just taken 2 away, and then I've taken 2 away from this side. So that plus 2 minus 2, that just gets rid of the 2. So all I'm left with here is the x, and then I've got 5 apples over here, and that's, as I said a second ago, that's what it's going to equal, okay? So the mathematical operation that describes taking apples away is going to be subtraction. So when we see an equation like this that is uses like a variable plus another number to solve that, you can use subtraction on both sides of the equation to try to solve it. Okay. Now we're going to imagine here that this equation is balanced on the pan, right? So we have 3 bags on the left side, and then we have 2, 4, 6, 8, 10, 12 counters or whatever, little squares on the right side. Okay. So then the question would be, well, how many cubes are in each bag? Well, if we've got 12 on this side and they're spread evenly over 3 bags, then I know that there's going to be 4 in each bag, right? That's how that's going to work out. Now in this one, again, similar kind of problem where the stuff is balanced, right? And so I have 4 bags on the left, and then on the right, it balances out with 4, 8, 12, 16, and 20. Okay, so again, if I've got 20 cubes on the right side, I know that, and I've got 4 bags, it's going to be 5 of these squares in each one, right? So I have 5, 10, 15, and 20. And so that's how that's going to balance out. Now, to write an equation, though, to just get beyond that diagram, that modeling stuff, if it also says to use B for the unknown letter. I've got 3 bags here. I'm going to write 3B for 3 bags, and I'm going to say that equals 6. So this means 3 times B equals 6. Okay? So I know that B is going to be equal to 2. I know that in each of these bags there's going to be 2 of these counters. Okay? That's not a real shocker. But this is, the question here says which operation. Now, when we talk about operations, adding, subtracting, multiplying, dividing, which operation did I use to write an equation for these models? These are multiplication equations. And then the operation that I actually used to find the number, I'm technically using division. So if I go back to these equations and I say, okay, well, actually, I'm even back up to the other one. I'm going to say over here, so I have 3B equals 12. What I've actually done is I've divided both sides by 3. Okay, I've divided both sides, and then so that what that does is similarly to subtracting out, I'm dividing out. I'm going from 3 bags down to just 1 bag, and in 1 bag it's going to be 4. Sorry that it's kind of squished. Maybe it'll be a little bit easier over here. And so I've got, rather than just write this out, say I've got 3B, and I'm going to divide both sides, not by B, sorry, by 3. Divide this side by 3, and then I'm going to divide 6 by 3 as well. So that's going to get rid of the 3's, and then all I'm left with here is the B, and then 6 divided by 3 is 2. And that's what I said here, that one of those bags is equal to 2. Okay? And so that's what I've done. When I've got a multiplication equation, to figure it out, I have to use division to solve the equation. Okay? Now, that gets us to this point. This is just a little diversion. But if I have 5 times 2 in brackets and then divide by 2, I can say, well, 5 times 2 is 10. I still got to divide it by 2. And then I get back to 5. Over here, I got 3 times 2 in brackets. That's 6 divided by 2. And 6 divided by 2 gets me back to 3. here I have 8 times 2, which is 16, divided by 2, and that gets me back to, you guessed it, my original number, which is 8. So multiplying a term and then dividing it by the same number will leave you with the same number, okay? So 5 times 2 divided by 2 is just 5. 3 times 2 divided by 2, just 3. 8 times 2 divided by 2, just 8, okay? So it doesn't matter what number we start with. If we're multiplying and dividing by the same number, it's going to get us back to that starting number as long as the multiplication and division is by the same number. And so what we need to do then is imagine, well, if we have, let's say we have some variable, let's say it's n. N times 3 divided by 3 is just going to be n. So it doesn't matter if we start with a variable, it's going to also get us back to the same number. And so that stuff is also, it's actually over on page 75. But a bit of practice here. So if we have b times 7, to get us back to b, we have to divide it by 7, right? b times 2 divided by 2 will get us back to b. b times 4 divided by 4 will get us back to b. And b times 8 divided by 8 will get us back to our original variable. And so to use that stuff, right, if we have 3b, right, we have 3 bags equals, and we have 3, 6, 9, 12, and 15, then I can say, well, that's 3b divided by 3 equals 15 divided by 3, because that times 3 divided by 3 is going to get us back to our original numbers. B here is going to just equal 5. Okay, so what we can do is we can actually circle 3 equal groups, because that's what we're doing. We're dividing 15 into 3 equal groups. And then what's going on here is, it says, imagine I remove 2 equal groups from each side, so only 1 equal group remains. The operation that I've performed is division. I've divided 3 and by 3 to get 1. I've divided 15 by 3 to get 5. The scales are still balanced, okay? And so that's important to notice as well. So I've got, in terms of the equation, what I'm showing here is b times 3 divided by 3 is 15 divided by 3, which leaves me with 1 bag, and in that bag is 5 apples. Okay, so to practice it out real quick, we could have like 2 bags, this is a multi-stepper, plus 3 equals 4, 6, 8, 10, and 11. So the first thing I want to do is get rid of the 3 apples over here. So 1, 2, 3. So then I'm left with 2b equals 8. And then what I can do is say, well, I need to divide it into 2 equal groups. So then, and then kind of erase that. So then one of those equal groups is 4. So one bag is going to have 4 apples. Now, to write that all out, I'm actually going to extend the page for a quick sec. Oops. And I'll just show it all the way. So I have 2 times b plus 3 equals 11. So I have 2 times b plus 3 minus 3 equals 11 minus 3. So that gets rid of that. So then I left with 2 times b equals 8. So then what I need to do is 2 times b divided by 2 equals 8 divided by 2. So that gets rid of the 2's over here. So then b equals 4. Kind of a long thing to do, but that's basically how it all works out. Okay, so bit of a long video again. I'm sorry. I'm trying to work and get it lower, but if you haven't been stopping and working on stuff, then page 73 to 76 is what you need to work on.